Right, so you're welcome to our class today. I'm Jarvis, and you're on to Marble with Jarvis. Today we'll be looking at a topic called number base systems, with special emphasis on binary numbers. So the textbook we're using is the New General Mathematics for GSS 1, and we are on page 893. We are on page 893, and so we will hit the road. If you're using that textbook, what's written on that page it's chapter 4, page 193, and the topic there is base 2 arithmetic. All right, so with our key objectives, what are the key objectives of this topic? Number one, we're expected to be able to expand numbers expressed in various bases. We're expected to be able to express base 10 numbers in base 2, and we're expected to convert binary numbers to base 10, and we are also expected to do addition, subtraction, and multiplication of binary numbers. So those are the key objectives we're expected to achieve on this topic today. All right, so the first thing we want to do is to understand, first of all, what is a number-based system? In one simple word, a number-based system essentially talks about a counting system. A counting system. So the reason we have numbers principally is to count. For instance, if I say 2, you may want to move your fingers. That's 2. If I say 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what then is a number? A number gives you an idea of what? How much? Quantity. Is that okay? So, looking at our counting system, counting systems are best explained in what we call bases. So conventionally, right from primary school till this time, you have been taught base 10. You have been taught what? Base 10. If you remember, you were taught something called 100, tens, and units. Is that not? So if I write a number, for instance, 2, it will mean what? Units. If I write a number like this, it will mean what? 10. If I write a number like this, it will mean what? 200. Emphasis on the digits. So these numbers are counted in what? Base 10. So in base 10, you usually will start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And once you get to 9, what you're going to see is what? Is 0, or you move to another digit. So if you get to 9, for instance, you're counting, the next thing you're going to write will be 10. This 10 you are writing is actually bringing in a 10th digit and then writing this one as in units. So 10 has 2 digits. Good. 1 and then what? 0. So read it as what? 10. But let's say we are counting in, let's say, base 5, for instance. It means that we will not see 5. Look at it. I start from 0, 1, 2, 3, 4. When I get to 4, it means go to 2 digits. When I get to 4, I must get to what? 2 digits. So my next number will be what? 1, 0, base 5. This in this counting system is not 10. It is what? 1, 0. 1, 0, base 5. So that's more like when we talk about the counting system. Let's take another one. Let's say we're counting in base 7. What we're going to have, we're going to start with 0, 1, 2, 3, 4, 5, 6. When we get to 6, we're going to have here 1, 0. And that will be what in base 7. Remember, in any counting system, in any base system, the base system is not counted. All right, the base number is not counted. Let me explain what that means, because it might be difficult for you to get what I'm saying. If I say base 7, don't count 7. 7 does not exist. Base 5, don't count 5. 5 does not exist. Base 2, don't count 2. 2 does not exist. Once you get to a number before that system you're counting, you're automatically going into a 2 digits or what? A 3 digits. So if it were 1 digit, you'll now be looking at 2 digits. If it were 2 digits, you're not going to a third. One thing you must take note of is that I will not be too detailed. I will look at objectives and will allow you after the class to now go back and see if you can understand the objective. So we start with the first objective, which has to do with expansion. Now, if you look at our text, the first objective we have is expanding numbers and expressing them it says here, expand numbers expressed in various bases. Now, when you expand numbers expressed in various bases, the objective is to try to write out their expanded form. So we can say expansion or what? Expanded form of any number. So we're going to take an example. For instance, I want to expand, let's say, let's take an example. Look at your textbook. If you look at exercise 24A, I want to do question number 1. Exercise 24A, I want to do question number 1. I want to do question number 1. And that question says, expand the following in the powers of their bases. 2, 3, 8, 9. Now, 2, 3, 8, 9 in base 10. I should expand this in base 10. Now, there is a trick you must take note of here. 2, 3, 8, 9. You know, I teased the concept. I hope you saw that earlier. In your primary school, this is units, this is tens, this is hundreds, and this is thousand. Are you seeing that? Units, tens, hundred, and what? Thousand. So this position is assigned 0. This position is assigned 1. This position is assigned 2. This position is assigned 3. Now, the big question a student may ask me is, how do I know that that is what it should be? I'm going to give you an example. From your understanding of what do you call it? Counting in your primary school. This is what? 10. This is what? 1. Sorry, this is what? 1. This is 10. This is 100. And this is what? 1,000. How do I know that? If I'm going to write these 2, for instance, this 2 appears on that 1,000, so it will be what? 2,000. This 3 appears on that 100, to be 300. This 8 appears on that 10, to be 80. And this 9 appears on that unit to be what? 9. What? Once. In your primary school, you would have been, if you're using the American learning system, we call this one once. Units are treated as once in the American curriculum or system of learning mathematics. Right, so with that said, if we add these numbers together, we're going to have 2, 3, 8, 9, 2,389 as the answer. But we need to write it in its expanded form. So how do we do that? Now, somebody would ask the question, why am I writing 0 here? We have a rule in maths. We have a very important rule in maths that says that, here is one important rule in maths that says that any number raised to the power of 0 is equal to 1. Any number raised to the power of 0 is equal to 1. So if I have any number, if it is raised or its index 0, it will be equal to 1. It creates ones because this digit is called the unit or the ones. Here, units or the ones. So this is called the unit or the ones. So anytime you're giving a number to expand, you need to write it in this format. So this one will back down. If I have to write it in its expanded form, if I have to write this in its expanded form, it will be 2 times 10 raised to the power of what? 3 plus 3 times 10 raised to the power of 2. We come to 8, and that will be plus 8 times 10 raised to the power of 1 plus 9 times 10 raised to the power of what? 0. 0 position, 1 position, 2 position, 3 position. Is that clear? 0 position, 1 position, 2 position, and what? 3 position. So with that, this is what you're expected to do in writing this number in this word expanded form. Is that okay? Is that okay? Okay, I'm sure that is good. So now let me give you one to do. Let's look at question number 2 now. We are to write in its expanded form 647, or rather, I just made a mistake and I need to correct that. It's actually 647 base 8. I will do more talk on that much later. 647 base 8. Now, could you write this in its expanded form? You have about 2-3 minutes to do that. All right, so with that said, 647 base 8 is not 647, no. The only time you have hundreds when you're counting in base. So what you do first of all, this will be equal to this. So you put the numbers on top. This digit is 0, this one is 1. Okay, so look at it. What do you have now? It's going to be, the last digit is always 0. This is 1, this is 2. So we're going to have 6 times, what base am I considering? It's base 8. So what power? 2 plus, what is the number? 4 times, what base am I considering? So what power? 1. Plus, what is the number I'm considering? Times, what base to what power? I say it, number, base, power, number, base, power, number, base, power. So look at it, number, base, power, number, base, power, number, base, power. I see that. So that is what we're expected to do there. So let me take number 3 very quickly. In number 3, we are told 3, 5, 3, 5, 1, 5, 4, base 6. 3, 5, 1, 5, 4, base 6. So how do you do that? The same process. Just write 3, 5, 1, 5, 4, base 6. The next thing you do is to write in, to fill in your powers. So this position is always 0, 1, 2, 3, 4. Is that okay? 0, 1, 2, 3, 4. Once you've done that, the next thing you want to do, is to take them now. In taking your answer, you take from this position. You take from the highest digits. So this will be number times base to power plus number 5 times base to power plus number times base to power plus number times base to power plus number times base to power. So with that, you have done that. That's what they mean by expanded form. That's what they mean by writing in expanded form. We're treating binary number system. And to understand this topic, we will try to look at. So, to understand any other base system, we must understand base 10. Base 10, why base 10? Because that's the system you have used all the while in your primary school. The units, the tens, the hundreds. So that's the system you've been taught in primary school to use to do your counting. So That said, beautiful. So that said, we now come to binary number system. So to do binary number system, we will try to convert the system we already used to base 10 to what? Base 2. So binary will mean what? Base 2. Another important word you must remember when it comes to this counting system is that base 10 is called denary. So base 10 is also called denary, and base 2 is called binary. So base 10 denary, base 2 binary. Don't ask me about the others. We'll talk about them as the need would arise. All right, so taking care of that. So we will start with base 10. So I'm going to do something here. Just follow me close. And I'm going to use the counting system we are used to. Start with 0, 1, 2, 3, 4, 5, 6. If I come here and say 7, 8, 9, and let's stop at 10. Let's just stop at 9 for now. Or let's stop at 10. It's okay. Get to 10. Now, what would it look like when you're counting in base 2? What would it look like? So, we're going to do this. So, for base 2, 0 will still be 0. For base 2, 1 will still be 1. Now, for a base, now please, I'm coming to this side of my board so you can see what's happening here. Now, for base 2, the digits or the numbers you use for combination are 0 and what? 1. So if I have 0, I have 1. After, I'm going to have what? 0 and what? 1. 0, 1. Because I said the highest number you can get to be what? 1. So if it becomes what? 0, it means that I'll have 1 here. Now, after this one, what will be the next number I will have? I can have 1 here, and I have what? 1. So I can have 1, 0, I can have what? 1, 1. After that, I'm going to have 0 here again. I'm going to have 0 here, and I'm going to have 1. I'll show you how we get this number, but I just want to play with them for now. Now, what am I going to have? I'm going to have 1, 0, 1. I'm going to have 1, 1, 0. I'm going to have 1, 1, 1. I see that 1, 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So after that, what can I have? I'm going to have 1, 0, 0, 0. I have 1, 0, 0, 1. I see that. Then I'm going to have 1, 0, 1, 0. I'm going to have 1, 0, 1, 1. Then I'm going to have 1, 1, 0, 0. Take note of something as we count. Take note of these two. What was happening here? Are you seeing it? Okay, fine. Not this one. Take note of this and look at this. Take note of this. So look at it. See what's happening. You're going to have that combination of 0, 1, 0, 1. So the last digit will either be 0, 1, 0, 1, 0, 1, just like that. And this will be what? 1, 1, 0, 1. And then you have 1, 1, 1, 0. And you have 1, 1, 1, 1. Now, the list can go on. But if I'm not going to, this is base 2, I cannot marry that to base 10. In base 10, what am I going to have? This will be 1. This will be 0. This will be 1. This will be 2. This will be 3. This will be 4. This will be 5. This will be 6. This will be 7. This will be 8. This will be 9. This will be 10. This will be 11. This will be 12. This will be 13. This will be 14. This will be what? 15. So notice something you should learn here. What's the most important information you should keep here? Anytime the number is even, it will end with a 0. Look at this. All even numbers will end with 0. Check. All even numbers will end with what? 0. But if the number is odd, it will end with a what? A 1. So anytime you are converting numbers from base 2 to base, or from base 10 to base 2, if the number is odd, if the number is odd, there is no way the last digit will be 0. The only time the last digit will be a 0 is if the number is what? Even. So that's what you need to know here. And the next stage will be for us to now try to show you how you can convert any number to binary. Let's assume I gave you this number now. I gave you a number and I want you to convert it to binary. How would you do it? So we've come to try to convert any number in base 10 to base 2. There are two ways you can go about it, but I will just use the method that is more of a standard to us. So I would want us to go to exercise. Let's see, exercise 24C. That is exercise 24C, page 196, question number 5. Exercise 24C, page 196, question number 6. And it says convert the following base 10 numbers into binary. So the first one given to me, the exercise 24C, number 6A, and the number given to me is 26. Now to convert 26 to base 2. Remember, anytime we have a number that the base is not stated, it means that that number is in base what? Base 10. So how do you convert this to base 2? Now, very simple. We use what is called the division method. What is called what? The division method. So we put the number here and we divide with the base we are asked to get to. So the number in base, this is only used when you are converting from base 10 to another base. But in this case, we are converting from base 10 to base 2. So we divide this by 2. So in this column, we'll be dividing by 2. And in this column, we'll be writing, we'll have the number we're dividing here. And if there's a remainder, we put the remainder here. 2 dividing 26 will give me 13. And there's no remainder. Why? Because it's an even number. 2 dividing 13, the closest even number before 13 is 12. So 2 divided 12 will give me 6, and there will be a remainder of 1. This is an even number, so division will go directly 2, and this will give me 3, remainder nothing. And here, 2 will divide 3, and I'll have 1, because the closest number, even number to 3 is 2. And I'm going to have 1, remainder 1, because the number here is odd. Now, 2 divide 1 is not possible. So it means that it will be a remainder. The trick after solving is that you read from bottom to top. You climb the hill from the bottom up to the top of the hill. So the answer will be what? 1, 1, 0, 1, 0. And it's in base 2. Remember, this number is not 11,000. It is not 11,010. It is 1, 1, 0, 1, 0, base 2. It's important you don't forget. The only time we count 200 and whatever is when we are dealing with base 10. If the number is not a base 10, if the number is not base 10, we will read it as each digit as it is there. So this is what that answer will look like. So I would expect you to go back to exercise 24C in page 196. I hope I got that right. Question 6. and try your hands on 6B onto 6H. All right, so we're done with that, and then we'll proceed. So we want to convert base 2 to base 10. We want to convert base 2 to base 10. Now, there's a trick I want you to remember here. If you're moving from base 10 to base 2, what you'll notice is that we were trying to divide. Now, if we're moving from base 2 to base 10, we will do the opposite. My famous talk about antonyms, synonyms and antonyms, or words and opposites. So we use the antonym. The antonym of division is multiplication. The antonym of trying to break down is to try to multiply or expand. To expand means to make large. So if you're converting from base 2 to base 10, we have to expand. So how do we do this? To answer this, we will go to our textbook and look at exercise 24C again, page 196, question number 7. So let's look at that. So exercise 24C, question number 7. And as usual, I'm going to do question A, which says 1101. 1101. 1101. So how do I handle 1101? Base 2. Please, you must always put the base there. Always put the base there. Sorry about that. So 1101 base 2. You must always put the base there. Is that okay? Now, how do we handle this? Very simple then again. Remember, we've taught you how to write numbers in their expanded form. Is that not? Is that not? Good. So the next thing we'll do now is to say 1101 base 2. And then we start from the lowest digit. We put a 0 there, we put 1, we put 2, we put 3. Then we write it out in its expanded form. This would be number times base to power, number times base to power, plus number times base to power, plus, this is 0. I'm going to show you something interesting much later on this, times base to power, plus number times, maybe I need to clean that off so I can have it well written out so that it's clear for us to see. Now look at this, number times base times power, number times base times power, number times base times power, number times base times power. Now look at this. This will be 1 multiplying anything is that thing. So this will be 2 to the power of 3. 2 to the power of what? 2 plus 0 multiplying anything will be what? 0. Whenever 0 multiplies anything to be what? 0. Plus 1 multiplied to the power of 1 will be what? 2 to the power of, to the power of 0 will be 2 to the power of 0. Now, what is 2 raised to the power of 3? 2 raised to the power of 3 means that we are multiplying 2 3 times. So this 2 to the power of 3 would mean that I'm saying 2 times 2 times 2. And what would that be? To do your multiplication right, that will be 8. Plus 2 raised to the power of 2 will mean 2 multiplied 2 times, and that will be 4. Plus, I'm adding 0 to anything, that thing will remain. So I don't need to write this one again. It's not necessary to me. Now, 2 raised to the power of 0. 2 raised to the power of 0 is what? It's another way of expressing ones or units. So that will be plus 1. Is that okay? So 8 plus 4 will give me 12. 12 plus 1 will give me what? 13. So You have successfully converted base 2, this number base 2, to base 10. Remember, by simply using a technique we started with earlier called the expansion technique. We'll bring our class to a close today, and I would expect you to go back and take care of all the assignments. I'll be forwarding more tasks for you to do, and I would expect you to take care of them. Remember, the easiest way to understand the concept, get involved. See you in my next class.